Hi, in this video, we're going to take a look at some graphing in polar coordinates. So let's take a look at this particular example. We have r is equal to 3 times sine of 3 theta, and we're going to graph this in polar coordinates. One of the things that's a little bit confusing about the way that the book describes this is they describe graphing it in rectangular coordinates and then imagining wrapping this around um, this circular region that we have here. But I'd recommend just thinking in terms of a graph. You're graphing points. And so let's make this a little bit larger. And what I'm going to do is I'm going to make a chart where I have the various points that I'm going to graph. So here's my chart. On the chart, I'm going to have theta and r. R is a function of theta. You'll notice that at least this graph that I have here, I have the grid is polar grid, where I have marked off the, let's see, this is pi over 12, pi over 6. That's 2 pi over 12. Basically, each of the pi wedges is pi over 12. So 2 pi over 12 is pi over 6, 3 pi over 12 is pi over 4, and so on. All the way around. Whoops, that should be a 12 there. Anyway, so that goes all the way around. So my suggestion to you when you're graphing a function like this is to start by graphing every single spoke until you see a pattern forming. And then maybe you can just exploit that pattern. So I'm going to start with 0, and then pi over 12, and then pi over 6, etc. So let's go ahead and graph these points. 0, the 3 times sine of 0 is 0. If you need to, you can punch this into your calculator, and I'm going to show you in just a bit how to actually graph this on your calculator, but there's that particular point. Pi over 12, we get 3 times sine of 3 pi over 12, and 3 times pi over 12 is pi over 4. Sine of pi over 4 is radical 2 over 2, so that's going to be 3 radical 2 over 2. With pi over 6, I get 3 times sine of pi over 2, and we know the sine of pi over 2 is 1, so it's just going to be 3. Then we'd have to do pi over 4 and so on. You know, before we go on, I'm going to pause this because I want to show you how to actually put the table on your calculator. So without giving away too much about this, the fun of using your calculator, let's just point out that if you press mode, and whatever calculator you have, I just have the TI-84 plus C here, but you're going to want to be in degrees, of course, you know that, and I want to find, why is this not operating the way I want it to? Perhaps I can't use this emulator. Pausing again. Okay, I've got my other calculator here, which is a TI-84 Plus Silver Edition, and make sure that you're in radians. We want to make sure that you're, and then we're going to go down here to polar graphs. So here we go. So there's polar, and then we'll click the y equals, and you'll have these r equals instead of y equals. At any rate, I'm going to type in 3 times the sine of 3 theta, because that's what I had back there. So let's see, 3 theta. And it knows that you're in polar form, and it knows that your independent variable will be theta in this case. So now that we've got that squared away, I'm going to use the table. If only I could see the stuff here. Oh, I see it. Okay, sorry, it's so small and my eyes aren't as good as they used to be. So first of all, I'm going to do table set, and I'm going to start at 0, and delta table is going to be pi over 12 to match the, so pi divided by 12 to match my graph back here. And then we'll just ignore all the rest of that, and then we'll go ahead and second table this thing. And you see that we have here exactly those numbers that I had written back here. You have at 0, the radius is 0 at pi over 12, which is this number. The radius is 3 radical 2 over 2, which is the same as 2.12. and then you have 3, and then it goes on from there. So I'm going to use this table in order to draw my graph. So let's see if I can get everything to be on the same screen. That's not too bad. Okay, so back to my graph. I'm going to start off by putting a dot at 0, 0, and then I'm going to move my way around. So the next spoke, I'm going to put it at 2.1 about, then at 3, then at 2.1 again, and then notice we go back to 0. So let's just connect those dots just to see how this looks. Make sure you connect them with a nice curve. When we do this on our calculators, it will not look quite as nice as what I'm drawing. Now moving on, let's go back here and see if we can move our way through this table. Let's get a next, there we go. So we're right here at this whoops. Okay, good enough. Okay, so we're at pi over 4, which is 1.04. The next thing that we get to is pi over 3. Now this is kind of confusing because you're on the pi over 3. That's I'm sorry, that was 1.04. That's pi over 3. So now we're at 5 pi over 12. That's 1.309. Anyway, you're on that spoke, but it says that we're supposed to go negative 2.1. So you're on this spoke. Here's positive on that spoke. And I'm going to go negative, which is back here. So go back to 2.1. And then the rest of this should make sense. 1.57 is pi over 2. Positive would be this direction. We're going to go negative, which is down here, to negative 3 on the pi over 2 spoke. So it's possible to have a negative radius. You just have to remember you're going backwards on your spoke, which is kind of the opposite direction. Then I've got this point, then I'm back at 0. So let's connect those dots. And then I'll finish this up. The next point, let's see, we are at, where did I go with this? I think we're at 3 pi over 4, which is 2.35. 3 pi over 4, it says that it's 2.1 again. Now I can guess where the next thing is going to be, but let's just go down here, get all the way to pi. Let's see, so we've got that point, then we've got this point here, and then the next point, and then when we get to pi, we're back at 0. So let's connect those dots as best we can. Now an interesting thing happens when you hit pi. When you get to pi, the next spoke, which is, I don't even know what that is, pi plus pi over 12, 13 pi over 12. You have a negative 2.12. So you're actually, so this is positive along that spoke. You're going negative. You're going back here to, here I'm going to have to change colors so that you can see what I'm doing. You're going back to this dot right here, the dot that we've already been to. So actually, when you trace this out, all you need is you need to graph everything from 0 to pi, and then the graph repeats itself, interestingly. So what you end up with here is this sort of flower curve. Let me show you how to do this on your calculator, though, because that's far more fun or quicker. So once you have this typed into your calculator, you want to press Window and make sure that everything is good with the window. You might have to adjust the theta step here, and then just click Graph. Now, what we get here is nowhere near as nice as what's back here. However, we can make it look nicer by doing our little trick here with Zoom Square. Let's see, Zoom. Whoa. I want to Zoom Fit. Where is it? Zoom Fit. Give it a minute to fit this, and then Zoom Square. So make sure you square it up as well because you want to make sure that it's there. So that's what we're looking at. Still not quite as nice as what you might get if you freehanded it if you were a good artist, but still not bad. Let's take a look at some additional problems like this. So we've already talked about this, that you have your mode as polar, your window, theta min and max, you want to set up those and so on. So here's some interesting curves that you might do at your leisure. Notice that what I'm doing here is I'm just changing the coefficient of theta. And you can do this really quickly on your calculators. In fact, I don't have the cosine here. I have 3 times sine. Let me move this over. So let me just change this to cosine. So let's see, cosine. There it is. So the cosine curve looks very similar to the sine curve. It doesn't fit, but don't worry about that. And so now you can quickly change that to 3 times cosine of 4 theta. And when you do 4 theta, check it out, something interesting happens. You end up with many more petals to your flower curve. You might, now here things are looking a little jagged, so here's where you might want to change this theta step to 0.05 or something similar. So graphing this takes longer, but it looks better. So what's happening here is that when you have an even coefficient of theta, you're going to find that you have twice as many petals as the number. So with the 4, let me show you this again. Let me get the bigger, there we go. So 3 cosine 4 theta, I have 8 petals. And the reason is that when you have an even number there, the curve does not retrace itself from 0 to 2 pi. Whereas if you have an odd number like 5, you will just have exactly as many petals as the number there, the coefficient. So there's 5. But it retraces, you can see it retracing itself as it goes through. Some other those are called Rose curves. Then we have these curves. These are kind of interesting. These are all called limacons, but some of them are different than others. So I encourage you to experiment with these. I'll just show you one of them. Let's do well, maybe I'll do 2 of them. So we have the 4 minus 3 times cosine of theta. There we go. Let's see, close parentheses and graph this. Whoops, go to error. Just a minute, I've typed something bad. Oh, that should be this minus, not the other one. Okay, now we'll try again. Oh, this is going to be a problem, isn't it? Because it's not, you can't see the whole thing. Anyway, that's called a limacon. Let me zoom out. Let's see, zoom. What was it, 0? Zoom fit. So I won't bother zoom squaring this. We'll just take a look at this. So it's called a limacon because it kind of looks like a lima bean, doesn't it? A squished down lima bean. Anyway, there's different flavors of limacons. I encourage you to take a look at some of these to see what they look like. Some of them have an additional loop in here. Some of them don't. That's kind of fun. When you start using polar curves, you can have these cool Valentine curves. And so if you're looking for a special card for your special friend at Valentine's Day, you might use something like this. That's the third one down. The first one is also a nice polar curve, but you could give them a card that looks like this, and then on the inside, you could do this. And that's the curve that you see there. R is equal to the absolute value of t minus pi over 2 all over pi. So we've talked about how to graph curves. We'll do one more video where we talk about these sort of WebAssign-like problems.